Okay. Hi people. Good evening. Am I or have I been made host already? No. They have to join and make me host. Okay, I made the host. Right. Right. So let us. So did you write test this week? Some part test, anything you wrote?
Yes, sir.
You wrote?
Yes, sir.
Okay. Was it chemical reactions and equations and acid bases and salts? The chemistry syllabus I'm asking. What was the portion for the test? It was full portions, or only some chapters were involved in chemistry for the test. Guys, are you able to hear me?
Yes, sir.
Okay, then why the answer is not coming? What is the issue? You don't know what chapters were there?
Sir, acid base in salts and chemical equations.
Acid, base, and salts and
Chemical equations.
That's what I asked. So is it chemical equations and acid, base, and salt? That's what I asked. Okay, fine. But I don't think they gave me the question paper, but they asked me to discuss this particular PPT because we didn't discuss it, it seems. Okay. So we'll discuss that PPT, which has both questions from chemical reactions and equations and acid base. So I don't know whether that is a question paper also. Let me know once I show you whatever it is. Okay, let me share my screen. Right. So let me make it a little big. Okay, I hope everybody is able to see. I don't know, this color will be fine. Okay. Right. So the first question is copper particles turn green when kept for long due to, obviously I know the answer is going to be corrosion, right? If you will call it rusting, only it happens in the case of iron, right? If not, if it's for some other element, then you don't call it rusting. The rusting is also a form of corrosion only, right? But that is only for iron, right? Okay, fine. Moving on. Next question. Okay, the name given to the expression of a reaction in terms of formula of reactants and products. That means we will not write the full names, we'll just write the chemical formula of the compound in the chemical what? Equations. Is it not? Chemical reactions, fully will write. Equations means make it simple, right? You'll only in terms of your formulas, you'll write chemical formulas of the compounds, right? Okay, next. Which one of the following involves chemical reaction? Keeping petrol in China dish in the open. Now, what will happen if you keep petrol in China dish in open? It will go for what? It will turn into gas, right? Right?
Yes,
What
sir.
process is it? Is this evaporation? Is it not? Or it is also called as boil, but it's not boiling. What is the basic difference between evaporation and boiling, people? What is the difference between evaporation and boiling?
So, while boiling, the particular substance will be heated to its boiling point, and during evaporation, the temperature won't, like, temperature substance won't rise. But
Okay, that's a good answer. Yes. So boiling means happening at the boiling point. The temperature is defined. Evaporation can happen at any temperature. Well, 25 degrees Celsius, or even if you have 25 degrees Celsius, say you pour water on the floor, after some time it's not there because it would have evaporated. We'll not say it got boiled, right? We'll say that it got evaporated. Here also, you can't call it as boiling, but you can call it as evaporation, right? That happens. So it's just that liquid petrol is going to become gaseous petrol. There is no chemical change happening there, only physical change is happening there. Okay. Next, storing of oxygen gas under pressure in a gas cylinder. Again, nothing will happen, right? Oxygen is only going to be there under some pressure. Again, nothing will happen. Okay. Liquefaction of air, again, a physical process, is it not? So we are going to have gas getting converted into a liquid. Say, for example, ammonia gas is converted into liquid ammonia, right? Or say hydrogen gas is converted into liquid hydrogen or liquid oxygen. Liquid oxygen is going to be used as, in your rocket fuels, right? In your liquid oxygen, we say, right? Anyways, that is the kind of physical change, right? Next, heating copper wire in the presence of air at higher temperature. Now, obviously, what will happen? Now, copper is going to get heated up. This is a combustion reaction also. We will be able to write a chemical equation also for this, right? So definitely copper is going to change its chemical identity to copper oxide because it is going to react with oxygen. So definitely D will be the answer to this question, right? Okay, moving on. Identify substance that loses water when heated. Obviously, that's very easy question, right? Loses water only which has water, right? Obviously,
Yes,
C is the
yes,
answer.
yes.
Okay, next. What is the color of this? FeSO4H2O?
green.
Okay, good. Okay, fine. Moving on. Okay, plaster of Paris is used by doctors for setting fractured bones. Yes, that's true, right? We know, right? When plaster of Paris is mixed with water and applied around the fractured limbs, it sets into a hard mass. Yes, that's also true, right?
Yes,
Okay,
sir.
now what happens? Now, once it has a half H2O, it is called what? Plaster of Paris. You mix it with water, right? It becomes gypsum. That is 2H2O, right? And that 2H2O again, after some time, once the whatever the bandage or the plaster whatever is applied, it will get dried because of evaporation. Now again 2H2O becomes half H2O and becomes POP again. At that time it becomes hard, right? So because gypsum is soft and POP is hard, plaster of Paris is hard. So you can understand. Okay, right. So there both assertion and reason are right, and it is the correct explanation, obviously. Right, that's why you're using it in setting up of fractured bones, because we'll be able to set nicely and it becomes hard, and that's why that is why it is helping in setting your fractured bones. Okay, so A would be the answer for this question. Next, what will happen if we add water to acid or a base? What will happen? What will happen, guys?
It is highly exothermic, sir.
One thing is we can say that it is exothermic. Any other thing you can say?
Like the water will splash out, and due to the heat produced, the glass might break.
No, any other, what to say? What will happen? They're asking, like in the sense that, can we say that the acid is getting diluted?
No, sir.
That also we can say. right? And we can also say that the amount of dissociation, that is all, that will also change in the sense that, say I have HCl and say I have added some 10 grams of water to this, and it gives me, I don't know, some 1 gram of H plus, right? It gives me 1 gram. I'm just giving you some random numbers. Okay. So HCl I'm having, right? It's already a solution. I'm adding 10 more grams of water to this, and 1 gram of H plus is produced, right? Basically, this is only producing my H plus after adding water, right? Now, same HCl, whatever the amount I had, now say I had 20, grams of H2O. If I add, the same thing will produce, I don't know, 2 grams of H plus. Right. So what you understand is more and more water I add, more and more they will dissociate into H plus and Cl minus. That's what you understand. There are a lot of inside things to this. Maybe you'll understand more when you go to 11th class. Right. So that is also a factor with the amount of dissociation. How much dissociation happens to give me H plus or OH minus ions? That also will change when I add water. Right. So all these points you can write for this question. Okay. Right. Next. Give one use of bleaching powder. Obviously, one using obviously is going to be using a bleaching agent for cleaning purposes, for disinfections, right? Cleaning agent is what you can use, what you can say. Right? Okay. Next. What is the relation between hydrogen ion concentration and the aqueous hydrogen concentration of an aqueous solution and pH? I don't know why are they asking you this, but the formula goes like this. Okay, pH is equal to negative log of H plus. When I say something in bracket, right, this bracket means concentration, right? Bracket of H plus means concentration of H plus. That's what I understand. Log isn't log is a term. I don't know. Have you used log books till now?
No, sir.
You're not used. Okay. When you go to 11th class, they'll teach you what is this logarithm. Mathematics will come. Okay. So log is like, a mathematical function like sine. How you write sine of x, like that we can write log of x. Okay. It's a mathematical function. Okay. Don't worry too much about it. Just asking about the relation, and this is never going to come in the examination. Don't worry about it. Okay. Right. Next, moving on. What colors do the following indicators turn when an acid is when added to an acid? Okay, litmus. Litmus, I know what is going to change. What is going to be the change?
Red litmus blue.
Red to blue is what will happen. Right? Methyl orange?
Pink.
What?
Pink color.
Pink color. Pink color in acid solution it becomes. Is it true? I don't think so.
It is colorless in acid.
No. It is no.
Sir, I think it turns red, sir.
Yeah, it turns red and yellow. Yellow in basic, I guess. Yellow in basic solutions. And I think it is going
Sir,
to
but
change.
they have asked acid, sir. So it's red.
Yeah, that's what. It is going to change to red in case of acid solutions. That's what is going to happen. So the answer would be red, and this is also red to blue. That's the answer to this question. Okay. Moving on. Shiny brown colored element X on heating an air becomes black in color. Name the element X and black colored compound is getting formed. The brown colored element obviously is going to be copper, which is going to react in air to form CuO, which is black in color. That's it. Right? We know this. Okay, this is your X element. Right? And what is the compound formed is CuO. Right? Okay. Next. Mention 5 ways by which rusting can be prevented. Okay, we have right.
Galvanization.
One is galvanization.
Painting.
Paint. Come wait, slowly. Let me watch. Yeah, painting definitely.
Alloying.
Electroplating.
Alloying.
Alloying is also.
Electroplating.
Electroplating is also okay. Then
Applying grease.
applying grease. And that comes under painting, you can say. And then have you known something called as cathodic protection? Have you heard this? Cathodic protection.
No, sir.
Cathodic protection. Have you heard of it? Okay, that is also one more method. Okay. So that I think I'll study again in 11th and 12th class. We'll study in your prevention of corrosion, electrochemistry. You'll study. Right? These are all the base. Okay, right. Moving on. Write the chemical formula of bleaching powder. I know it is CaOCl twice. Right. Fine. How bleaching powder is prepared? We know CaO is going to react with Cl2 and water. That's it. Plus H2 also. Right. And we are going to form CaCl2. We are going to form CaCl2 plus CaOCl twice. That's what we are going to form. This is the reaction. Right? Okay. Next. Give the chemical equation for preparation of lime. Lime is what? Lime is CaOH twice. Is it not? No, lime is CaO, isn't it? Quicklime is CaO. Later lime is CaOH twice. Okay, I think lime, when they mention benzoate, is going to be CaOH twice. Okay, fine. So in that case, we will write CaO. I will mix it with water to form CaOH twice. That's one way we can prepare. If it was CaO, right? Now, how could I have prepared this? It would be calcium burning with oxygen to form CaO. That is another way of if it was CaO. Right, but it is for CaOH. Next, moving on. 2 grams of silver chloride is taken in a cyanide dish placed in sunlight for some time. What will be your observation in this case? Right, the chemical equation involved in the form of balanced chemical equation. Identify the type of chemical reaction. Okay, very simple. So AgCl is going to be there, and I'm going to put it in sunlight. Next to, right, it is going to be, yes. So it is going to become chlorine gas. It is going to become, right. So now this will be a solid, this will be a solid, this will become a gas. And you're taking 2 grams of this, right? Now, when you observe, when you measure the China ditch again, it will be less, definitely less than 2 grams. Why? Because some amount of chlorine escaped as gas, right? Right? There will be reduction in the mass. That's what they're asking. What will be your observation in this case? You'll tell them the mass will become less than 2 grams. It's almost as if the law of conservation of mass is not getting utilized here, but no. It is getting utilized, but that mass is getting evaporated, or say it is getting escaping in the atmosphere. Okay, write the chemical equation as well. Wrote the chemical equation and you have to balance it, right? So we can put 2 here and 2 here. Right? 2 AgCl gives me 2 Ag plus Cl. Right? Okay. Identify the type of chemical reaction. I know what it is. It is your photolytic decomposition, right? In front of the sunlight, it is happening, and it's decomposition reaction. Right, so this will be your photolytic what decomposition. Right, moving on. What happens when a solution of potassium iodide is added to a solution of potassium lead nitrate in a test tube? Okay, we'll write the reaction first. Potassium iodide is Ki, lead nitrate is PbNO3 twice, right? And that is going to give me this double displacement reaction, PbI2 plus KNO3. Right? We know it's a famous reaction. It's going to be a precipitate, and that too it's going to be an yellow color precipitate. Right? That is what it is. Right? So, what is the type of reaction? You can write 2 answers to this. One is that you can write it as a double displacement, as we expect. Right?
And precipitation.
Or, yes, it's also a precipitation. Where your PbI2 is getting precipitated as an yellow precipitate. Okay, write the balanced chemical equation that we can do. Say I put 2 Ki and that's it, balanced. Right? Okay. Next. A chemical compound X is prepared by using sodium chloride as a starting material. Okay, fine. Compound X is used for faster cooking. Okay. I also find it an ingredient in medicine to treat indigestion. Here itself, I will be able to get the answer that this is going to be NaHCO3.
Baking
right?
soda.
Baking soda. Is it not? Right? So obviously we'll be able to prepare. Okay, identify the compound X. This is your X, right? Give an equation, give a equation for chemical reaction derived upon Heating X during cooking. Okay, but now we know what happens. NaHCO3 is unstable on heating. It is going to form Na2CO3 plus O2 or CO2. No, H2. That's it. Okay, that's what is going to happen. Right. Which quality of compound X makes it suitable for treating indigestion? Now we know indigestion happens because of acidity. So this is a mild or
Carbon dioxide also, no, sir, on heating.
NaHCO3. No, I think this is what it is. I don't think carbon dioxide will come. Or because only if I strongly heat this, then also carbon dioxide won't come. Only if I make it react with an acid, at that time it will give me carbon dioxide. Isn't it? For example, if I make Na2CO3 react with HCl, you will form NaCl plus H2O plus CO2. At that time, CO2 will come. Here it won't come. Okay. Right. So yeah, which quality is getting used for making it sitting indigestion? Obviously, indigestion is happening because of acidity, right? So we are treating it because we know that is going to be a mild base, a weak base, right? That will be neutralizing this acid. That is the cause for indigestion.
So in
Right?
a textbook, it is given as CO2, sir. Like carbon dioxide also come.
Carbon dioxide also comes. Okay, maybe fine. We'll take carbon dioxide also then. Not a big deal. Okay. Fine. Moving on. While eating food, you spill some curry on your white shirt. You immediately scrub it with soap. But what happens to its yellow color on scrubbing with soap? What happens to the stain when the shirt is washed with plenty of water? What is asking? Immediately scrub. What
So
happens
as
to
turmeric is a natural indicator, the stain will turn red because when it reacts with the base, it turns red. And then when plenty of water is washed again over it, I think it regains back its yellow color. So
So you're telling that, okay, turmeric is going to be basic. It is going to react with soap to form red color, right? And if you wash it with a lot of water, it is going to again go back to its yellow color, is what you're trying to say, isn't it? Is it or
Yes.
different? Okay, that's only, yeah, that makes sense. Right? So obviously we understand that turmeric is going to be a little indicator for base, right? So I know soap contains base, right? So the bases are, we say, soapy to touch, right? So when turmeric is going to react with the base, it is going to have red color. That's a natural indicator, right? And if I'm going to wash it after a long time, all these curry, this thing will go, soap will go, and eventually again only the curry will remain in your t-shirt or shirt. So it comes back to yellow color. That makes sense. Good, good. Moving on. Okay, you are provided the following substances: iron, nail, copper, sulfur, BaCl2, Cu powder, ferrous sulfur, quicklime, etc., etc. Write 5 reactions using these substances. Okay, fine. Okay, now one reaction I can write between these two, right? We can write Fe plus CuSO4 gives me FeSO4 plus Cu, right? This is a famous reaction also. Okay. Next, we have, say, for example, we'll take BaCl2 with what? Ferrous sulfate crystals. This is also fine, right? Now, when I do BaCl2 plus ferrous sulfate is FeSO4, double displacement reaction can happen to form what? To form BaSO4. This is a precipitation reaction also because BaSO4 is going to be precipitate, we know, right? Plus FeCl3 or FeCl2. Okay, right. Next, 2 reactions done, right? So we'll take quicklime. Any reaction can be made. Quicklime is what? CaOH twice, isn't it? No, quicklime is CaO. So what you can make it CaO. CaO with copper sulfate doesn't make sense. Copper with CaO doesn't make sense. Ferrous sulfate with CaO. Iron with CaO. No, this is actually a wrong thing to give in this thing. It will not react to the. No, it doesn't make sense to give a proper reaction as such. Okay, fine. So we have, say, copper powder. If I have to use copper powder, what I can do? No, which is more reactive, iron or copper?
Iron, sir.
Iron is more reactive. So this reaction is okay, right? But if at all I have to use copper powder and write your ferrous sulfate crystals. Yes, Kana, tell me.
So we can directly heat copper, no, sir.
Directly, but O2 is not given as such. Right? But yeah, if at all you heat it, yes, you can say that Cu plus O2 giving CuO or Cu2O will be formed. That is one reaction you can write. And quicklime is CaO, but then nothing will going to happen. Okay. So then what? Say iron nails also, I can do the same thing then, whatever we did for copper. Okay. So we did 4. Hmm. Very bad set of.
We can heat ferrous sulfate crystals.
That's a good one, I guess. Yes. Ferrous sulfate crystals will be .7H2O. When you heat it, we'll get Fe. I don't know. We'll get FeSO4 .7H2O plus 7H2O is what we'll get. That is also okay. Right. Fine. Again, same way for copper sulfate solution. Also, you can do CuSO4.5H2O will give me CuSO4.5H, mean plus 5H2O. That reaction also I can write. Okay, fine. Moving on. Oh, that's it. What we have. Next, what is a salt? Right? A salt is a product of an acid-base neutralization reaction. That is what you write. Right? Okay. Give names and formula of any two compound. Okay, this scenario is too much, right? They can write sodium chloride, aluminum chloride, blah blah blah. Thousands are there. Right? Okay. Also, name the acids and bases from which these salts are maybe obtained from. That's a good question, right? Say, for example, we'll take NaCl, right? I know how is it going to form, right? HCl and
Yes,
Na,
NaOH.
right? Say, if I give you NH4Cl, then it is coming from where?
Ammonium hydroxide and hydrochloric acid.
Absolutely. Ammonium hydroxide plus hydrochloric acid is going to give me this. Like this, you can do so many things. We have even seen this, right? Once a salt is given to you, what you should do to get the acid and base. If I can just remind you what we have to do, take the cation of the salt, right? Cation plus OH minus will give you what the base is, right? Whereas your anion plus H plus will give you what the acid is. You can see for this, for example, Na plus, you add OH minus to that, you get NaOH, right? The anion is Cl minus, to that you add H plus, you get acid. Okay, right. What is meant by, okay, next one. Okay, next. What is meant by family of salts? Now, family of salts means there is an acidic salt or basic salt or neutral salt or whatever it is. You know, strong acid, strong base will give you neutral. Strong acid, weak base will give you acidic, and weak acid, strong base will give you basic salts. That's what is called or by family. And I can explain the example. For example, this would be a neutral salt, right? Whereas this would be an acidic salt. Why acidic salt? We know NH4 is a weak base, right? Whereas HCl is a strong acid, right? Like that we would speak. Okay, next. What is meant by hydrated and anhydrous salts? Example, you can give a Humpty number of examples. CuSO4.5H2O is hydrated. CuSO4 is anhydrous. Right? Same goes with your FeSO4.7H2O. You can do. Okay. Next. Write the names, formula, and colors of any two hydrated salt. Again, you can take copper sulfate is blue and your ferrous sulfate is green. Right? That you can again write. What will be the color of litmus in an aqueous solution of an ammonium chloride solution? Now we know ammonium chloride, that's what we took, acidic. So what will happen? Now you'll see that litmus will again going to, I think this is going to be very weakly acidic, but still it will be able to change. Okay, assuming the fact that again it is going to become red to blue. Sorry, yeah, that's what is going to happen. Right, with the color of the litmus because it is acidic. Okay, moving on. I think we are done. Yes, we are done. Oh, okay. Any other doubts? Any of you has? Any of you have? Guys?
No, sir.
Okay, then we'll see again whenever you are. Is it the test paper which we discussed now? Whatever you wrote this week, is it that test paper?
Sir, yes, sir. I think.
Or the same test paper only? Okay, that's good. Okay, fine then. We'll see people next week. Bye bye.
Okay, sir.
Thank you, sir.
Thank you, sir.